All right, welcome to This Explainer. Today, we're tracing something that is honestly, truly extraordinary. May 27th is without a doubt one of the greatest dates in the entire history of mathematics. On this one single date, across completely different centuries and countries, a very specific group of brilliant minds were either born or passed away. And when you put their work together, it literally built the modern world we live in right now. Let's dive right into this timeline. Spanning from 1907 all the way up to 2012, these aren't just random years we picked out of a hat. Every single dot you see represents a mathematical genius whose life either began or ended on May 27th. We're going to treat this like a detective story today and follow this incredible thread. So let's start with a bit of a mystery. Have you ever actually stopped to wonder how your phone's GPS or Google Maps always manages to find the absolute fastest route? I mean, even when it has to navigate through hundreds of twisted, overlapping, super complex roads, how does it instantly just know the shape of the physical world around us? Well, the answer actually goes all the way back to May 27, 1907, and a guy named Herbert Seifert. He was a brilliant German mathematician who dedicated his entire life to something called topology. Basically, that's the math of connected spaces. Seifert studied three-dimensional fibered spaces. You can kind of think of them like woven threads. And he figured out the mathematical rules for exactly how complex paths connect to each other. Fast forward to today, and we use his foundational concepts to build the invisible digital road networks that our apps use to guide us home. And that leads us to this fascinating, almost mind-bending realization. Invisible mathematical shapes guide your every journey. Seriously, without the math of connected spaces, our digital maps would be entirely, helplessly lost. Okay, let's keep moving. We're still on May 27th, but now we're going to jump forward to the year 1925. And this time, we are looking up at the stars. Here is our next big question. How do we actually know what distant stars are made of? Think about it. We've never traveled to them. We've certainly never taken a physical sample. And yet we know exactly what elements are burning billions of miles away. How on earth is that even possible? The answer takes us back to May 27, 1925, with the birth of an incredible scientist named Adelina Gutierrez Merino. She was actually the very first Chilean to earn a PhD in astrophysics. Adelina used something called photoelectric photometry to measure and essentially read the light coming from southern stars. By applying really strict mathematical parameters to that starlight, she proved we could decode exactly what those stars are made of. And you know what? We still use her incredible legacy today to map out the deepest, darkest corners of our vast universe. It really kind of changes how you look at the night sky, doesn't it? Every twinkling star is sending us a mathematical message. The cosmos isn't just a bunch of empty space. It's a giant, readable math puzzle, just waiting to be solved. Same date, but just 3 years later. Now we're going to jump from the massive distant stars all the way down to the microscopic level, right here on Earth. Think about the device you're using to watch this explainer right now. Have you ever noticed how your smartphone or your computer screen displays millions of crystal clear colors so absolutely perfectly? How does it organize all that light with such precision? Well, the answer goes back to May 27th, 1928. Which is the day Arthur Schoenflies passed away. Now, he wasn't a computer scientist. He obviously lived way before smartphones were even a thought. But he classified the exact 230 space groups. Those are the geometric patterns that crystals can form in 3 dimensions. Today, the liquid crystal displays, what we call LCDs, that meticulously control the light in your screen, they rely entirely on the complex geometry he mapped out way back in 1891. Just take a second to really let that sink in. The screen you are looking at right now is built on the mathematics of crystals. An abstract discovery made well over a century ago is literally sitting right there in the palm of your hand. One single date. So many incredible stories. Let's keep going. We're transitioning forward now to 1962, because as our world gets faster and more complex, this math, it gets even more essential. Here is a real wonder for the digital age. Every single time you send a text message, make a payment online, or log into an app, your data is protected. But how do computers instantly sort through millions of numbers to keep our digital data locked away and totally safe from hackers? That answer traces back to May 27, 1962, the day we lost a brilliant mathematician named Felix Behrend. He absolutely mastered number theory and combinatorics. By looking at these endless seas of numbers, he deciphered the hidden rules for how they group together to form sequences. And today, the encryption algorithms that act as invisible shields for our private data are built squarely on his number theory. Behrend's work is exactly what helps us understand the hidden structures that computers use to organize and protect our most sensitive digital info. Which brings us to this pretty amazing realization. Hidden number patterns protect our most important digital secrets. Pure abstract numbers are basically the ultimate security guards of the modern world. All right, let's jump ahead on our timeline again. This single date's legacy continued well into the 21st century with minds like Friedrich Herzebruck in 2012. But let's pause at the year 2004 for a second so we can step into a completely digital dimension. If you're a gamer, this one is definitely for you. How do modern video games build these massive, three-dimensional worlds that look completely, stunningly real when it's all being displayed on a totally flat screen? The answer connects to May 27, 2004, the day the great Soviet mathematician Mikhail Postnikov passed away. Postnikov was an absolute master of algebraic topology. What he did was figure out how to take really complex continuous three-dimensional shapes, which are called polyhedra, and classify them using pure algebraic equations. Now, computers don't understand physical shapes, but they definitely understand algebra. So by turning 3D geometry into algebra, mathematicians like Postnikov laid the entire groundwork for modern computer graphics engines. It is exactly how your gaming console calculates and renders those incredible realistic landscapes in real time. So the next time you're exploring a digital universe, just remember this. The breathtaking 3D worlds in your favorite games are really just algebra in disguise. It's just pure math, working under the hood at absolute lightning speed. Take a look at this timeline just one last time. All of these incredible minds, from Seifert's topology to Postnikov's digital landscapes, they are all connected by this one single day on the calendar, May 27th. Different countries, different centuries, completely different technological challenges. Yet every single person we met in this explainer asked the exact same fundamental question: what is the pattern hiding inside the chaos? And because they have the curiosity to look for those patterns in crystals, in the stars, in shapes, and in endless numbers, our world today has GPS, smart screens, secure data, and immersive 3D games. Mathematics isn't just boring numbers on a page. It is quite literally the invisible engine driving our reality. So what patterns will you discover next? Keep wondering, keep questioning, and hey, thank you so much for joining me